infinite geometric series, meaning that we asked to find the sum of the geometric series, geometric sequence that goes to infinity. We are given two series here. We can write the first few terms to get the feel of this. So the first term, when we put 1 in for k, so that we have 9, 1 over 8, k is equal to 1, so 1 minus 1 is 0, and the next one where k is equal to 2. We don't have to do this, but to just get the feeling of what the series has. What's the pattern of the series? 3 minus 1. To simplify this, we will have 9 plus, that is just 9 over 8, and then 9 over 64, and so forth. Again, let's just review the formula for geometric sequence. A sub n equal to a1 times r to the n minus 1. And so in this case, this 9 is a1 is 9, and this gives us a common ratio of 1 over 8. Right. But we are interested to find the sum where it goes to infinity. Right. So for geometric series, the sum is equal to, I should write the formula somewhere. The sum is equal to a1 over 1 minus r. This only if r is between -1 and 1. We get more details of that in a minute. But here we see that the first term is 9, the ratio is 1 over 8. So we can just say we use that formula, and the first term is going to be, let's just write the formula out. Because the ratio here is between -1 and 1. So we say 1/8 is between 1 and -1. So that's one check. So we can use the formula. It's 9, 1 minus 1 over 8. So we have 9, 1 minus 1 over 8 is 7 over 8. Divide by 7, 8 is multiply reciprocal. And we have 72 over 7. Right. I'll make a few comments here. That is the answer, by the way. First, we see that since the ratio is 1/8, this number gets smaller and smaller and smaller as it goes to infinity. If that number is not getting any smaller, if it's getting bigger, we will not have the sum. This have to be getting smaller and smaller, and that's why the ratio has to be between -1 and 1. It could be negative as well, but the absolute values of the numbers have to get smaller and smaller as it goes to infinity. And that alone is not enough. So the precise statement is that the common ratio has to be between -1 and 1. So in that case it is. So we use the formula, and we have 72 over 7. Right. Next, for this sequence, we see that the first term is 1 over 7. The common ratio is 2. We know that 2 is not between -1 and 1, so this one is not convergent, or we say divergence. It is divergent. Right. But let's just write a few terms and see what that would look like. If we put k equal to 1, so we have 2 to the 0 power, so that's just 1 over 7 is the first term. The next one is 1 over 7 times 2. and the next one is 1 over 7 times 4, and so on. And let's just say 1 over 7, 2 over 7, and 4 over 7, and this just the term just keep getting bigger and bigger, and it goes to infinity. So there's no way this has a sum. So we say the sum diverges. So you see, it makes sense. If the term just keep getting bigger and bigger, we will not have a sum. Or we just use the formula. If the ratio is between -1 and 1, the sum is equal to the first term divided by 1 minus r. The formula works for every r, but in this case r equal to 2 is not between -1 and 1. And we say 2 is bigger than 1. So this condition is not satisfied. So it is divergent. So pretty much this problem just involve the formula for the infinite geometric series. It's just that formula. Just make sure that the ratio has to be between -1 and 1, and it's not equal to, have to be less than 1 and greater than -1. And that's what we have.